So we've been expanding with either the distributed property or with FOIL. So now we're kind of going to do the opposite. We're going to start with common factoring. Okay, if you guys do common factoring last year at all? No factoring? Okay, what they put in the grade 9 unit curriculum. Okay. So we've been talking a lot about polynomials, okay? Just long numerical expressions. So a polynomial is factored when it's written as a product of polynomials, okay? So product just means multiply. Okay? And factoring is the opposite of expanding, okay? Just like addition is the opposite of subtraction, division is the opposite of multiplication. Factoring is the opposite of expanding, okay? So what we did is we used the distributed property, right? If we had a number up front, we multiplied it by everything inside the bracket. This time we're going to go the opposite way. If they both have A, we can take the A out, and we're left with only B and C. Okay? So, let's do some practice first, okay? So what is the largest number that can be divided out of each of the following lists, okay? So what's the biggest number we can divide into 25, 5, and 35? What's that? Perfect, 5. Because if we do 25 divided by 5, we get 5. If we do 15 divided by 5, we get 5. If we get 35 divided by 5, we get 5. Okay? So the GCF, or greatest common factor, okay? So it's the greatest thing. Hey, bud. That can be multiplied into everything. 2. Because we can divide 16 by 2, we'll get 8. 14 by 2, we get 7. And 28 by 2 is 14. Okay, so our greatest common factor will be 2. So sometimes you might have to try a couple different ways, okay? I also have some factoring charts. I don't think I have enough copied yet. But I'll hand this to you guys on Monday when we do a review. No, Tuesday.
Tuesday, we don't sell
It lists all the common or all the factors for every number from 1 to 100. Just kind of help you kind of see, and then you can see which numbers are in both of them. Okay. Next, we have -2, 8, or -8, and -16. What's that? Perfect, -2. Okay, so since we have the negative there, we're going to divide by the negative as well. Okay? Because -2 divided by 2 would be 1. -8 divided by 2 is 4. And -16 divided by 2 is 8. Okay? So they all work out to be whole numbers when you divide. So the greatest common factor would be -2. Not just 2, but since they're all negative, it's negative as well. Okay, and our last one, 9, 15, and 36.
3.
Perfect. 3, because we divide by 3, we'll get 3 divided by 3, we get 5, and divide by 3, we get 12. Okay? So sometimes you might have to try a couple different ones before you find your one that works. But for like 16, 14, 28, if they're all even, always check for 2. Okay? So if all your numbers are even, they can always be divided by at least 2, and they can try going up from higher numbers from there. Okay? Sometimes you might find a factor, but it's not like the greatest common factor. When we talk about variables, though, we want the lowest exponent. Okay? The smallest exponent that appears in all the terms. Okay? Because do you remember what happens when you divide bases with the common bases with different exponents? Okay? So out of x cubed, x to the power 5, and x squared, what has the lowest exponent? 2. Okay? So x to the power 2 would be our greatest common factor because when we divide variables with the same base, what we do is we subtract the exponents. Have you guys seen that yet? No? Okay. So that works out to just x. Okay? So when you have variables with the same base, with different exponents, we subtract them when we divide. Okay? So then, there's not too much room for all this. So if we did x to the power 5 divided by x to the power 2, we get x to the power of 5 minus 2, which would be what? X to the power of 3. Perfect. If I did x squared divided by x squared, it's just whatever it is divided by itself. So anything divided by itself is always 1. Okay? So let's write this off to the side. When you divide exponent or divide variables, you subtract the exponents. Okay, so let's write that to the side here. Okay, if I have y to the power of 8, y to the power of 4, and just y on its own. Perfect. Y is the lowest. Okay, because that's technically y to the power of just 1. Okay, so then when we factor it out, we just take away 1 from each of those other exponents. Okay, so these are a little bit more complicated than just the numbers, but we're just going to look for the lowest exponent always. Okay, so to find the greatest common factor, or GCF, of a polynomial, we have to include the greatest common factor of the numbers. So the largest number that can be divided to each of them, okay? The largest number and the letters, okay? And we want the smallest exponent of them, okay? So biggest number, smallest exponent of the letters, okay? And that's how we find the greatest common factor of the whole polynomial itself. Okay. Okay? So that's what we're going to look for in each of them. Okay. So there's some rules that we have to follow when we common factor. So first, the greatest common factor must be able to be divided evenly into each term, okay? So by evenly, we mean no decimals. So you can try it on your calculator, just make sure that they all divide out evenly. But if whenever you try it, it doesn't, or you have a decimal, that means you have to try a different factor, okay? Sometimes it'll just be a number, sometimes it's just a letter, and sometimes it's a combination of both, okay? So check to see if there's a number that can be divided into all of them. Check to see if there's a letter. If there's both of them, then it's going to be both. If there's only a number that can divide into all of them, then it's just a number. If it's only a letter, then it's just a letter. Okay? So it can be number only, letter only, or both. Then, if the first term, so your first one, is negative, then you have to factor out the negative number. Okay? So that means if the first number is negative, we're going to be factoring out negatives out of every other term. Okay? Because we always want the first term inside the brackets to be positive. Okay, we'll see that in just a minute. We'll do some examples. If the greatest common factor divides fully out to the term, then you must show as 1 in this place as your final answer, okay? So it doesn't become 0. Okay? And that's going to lead into point number 5. So, no decimals. Common factor might be a number only, could be a letter only, or it could be both. A combination of both. Okay? And 4 will lead into 5. But you always want to keep the same number of terms, okay? So if the original polynomial has 4 terms, so you have 4 things, then there's going to be 4 terms in the parentheses or in the brackets. Okay? So if we're starting with a trinomial, that's going to have 3 terms. We'll have 3 terms inside the brackets. If we're starting with a binomial, that has 2 terms, 2 terms inside the brackets. If we have 4 terms, we'll have 4 terms inside the brackets, okay? If you don't have anything left inside the parentheses that's common to all the terms, you cannot have anything left that's also in common, okay? That means that you didn't have the greatest common factor. So if you factor everything out and then you see that all the numbers are even, then you can also factor out the 2. Okay, so you just might have to go back and get a bigger common factor. And then if we distribute back in, you'll have the original question back, okay? So that's how you can check your answer. Okay, so you can check to see if you're right. What you do is you distribute your greatest common factor back in, and you should get the original question that we had at first. Okay, so you can double check all your work with this stuff, okay? So I'll probably show you how to check for the first one and then kind of go from there. Okay, it'll make a lot more sense once we start doing some examples, okay? So number 1, we have 8a plus 12b minus 2c. So first, let's check to see if there's a number that can divide into each term. 2, perfect. They're all even numbers, so we can divide 2 into all of them. So what you do just kind of do a line to show that's divided by 2. And divide this one by 2. And divide that one by 2. Okay? So we divide all of them by the same number. Then we'll go equals. And we're going to put our common factor, our greatest common factor, 2. It goes first, and then we'll go set up some brackets, okay? So your greatest common factor goes on the outside. Goes outside the brackets. Now inside the brackets, we're going to write whatever this equals, okay? So it's 8 divided by 2. 4a. 4a, perfect. So 8 divided by 2 is 4, and then the a still stays there. Perfect.
6b.
Perfect. Then we have plus 12 divided by 2 is 6, and we have a b there. Then minus
C.
perfect. Minus just c by itself. Like technically, it would be 1c, but whenever there's a 1 in front of a variable, we don't need that 1. Okay, so it'll just be c by itself. And then this is our final answer. Okay. And then I said you could check your answer, right? So what we do is we distribute the 2 back in, and we have 2 times 4a plus 2 times 6b minus 2 times c. Then 2 times 4a would be 8a, plus 2 times 6b is 12b, minus 2c, and it's the exact same answer, right?
Yes.
So that's how you know, that's how you can check your work to make sure that you got the right answer, okay? So if you're doing a quiz or a test where you have to factor something out, and you have time at the end of the test, you can double check all your work. Okay, we're not going to do that for all of them though. That'll just be for the first one, just to show that you can do it. Number 2, 24, a to the power of 5, minus 12, b to the power of 4, plus 35, x squared. First, check, is there a number that can go into all these coefficients? No. Because 24 and 12 are even, so there could be 12, could be 4, but they won't go into 35. The 35 has 5 and 7, but they can't go into 12 and 24. So, no common number. Next, is there a letter that's common to all of them? No, they're all different letters. Okay? So if we don't have any letters and we don't have any numbers, we can't factor it. Okay? I'm not going to give you any like this, but sometimes on like the homework sheets, they crop up. Just want to show if you don't have any of the same numbers or any common numbers, none of the same letters, then you can't factor it, okay? And that's okay as your final answer. Okay? But these only crop up in like the homework worksheet sometimes if I steal them off of Google, okay? That's why I just want to show sometimes there'll be questions that you can't factor, but most of the time you can fully factor them, okay? Next, we have 7x cubed minus 8x to the power 5 plus 5x squared. Are there any common factors for the numbers? See some head shakes? No. So no common numbers. What about letters?
Yes.
Yeah. So they all have an x, right?
Yeah.
So what do we do for variables? What do we look for? Perfect. We look for the smallest exponent, which is what? Perfect. X to the power 2 is the smallest exponent. So our greatest common factor is x squared. Thank you. And here. There you go. So what we do, our greatest common factor is x squared. That goes outside of our bracket. Okay? So now, because we're only dividing out the x's, our numbers are going to stay the same, 7. But now we have x cubed divided by x squared. So I'm going to subtract 3 minus 2, which is
1, so just x.
1. So we just have x by itself. Okay? So if you ever have it where you get x to the power of 1, you can just write x. If you write x to the power of 1, that's right, but it just looks weird. Okay? Minus 8. We don't have any numbers to divide out. 5 minus 2 would be 3. So we'll have x to the power of 3. Okay, and then plus 5. X squared divided by x squared is, it's just 1, okay? So we would have 5 times 1. But what happens is it just cancels out fully and we're just left with the 5. Okay? So whenever you divide out letters like that, you'll always have one that doesn't have any more letters with it. Okay, so it's just 5 on its own. Okay, number 4, we're changing the letters to m. So we have m squared minus m cubed. So we know that we don't have any numbers that are going to be in common. But they're both m's, right? So we're going to have a common letter that we can factor out. So we look for what with letters? Exponents. Okay. So we're going to divide by m squared or m cubed? M squared because it's the smaller one. Okay. So we put our common factor right here. I forgot to show that here. So the common factor goes out front. We have m squared times. Just like when we said x squared divided by x squared was 1, what would m squared divided by m squared be?
Would it be nothing? Because you're canceling it out.
It wouldn't be nothing. It becomes not just m, something in between m and 0. 1, perfect. Okay, so just like when we divide like 6 divided by 6, that equals 1, or x divided by x equals 1, m squared divided by m squared equals 1, okay? Anything divided by itself always equals 1, okay? So it's not 0 because then we won't have a binomial inside the brackets anymore. It'll just be a monomial. Okay? The minus m cubed divided by m squared would be, sorry, just m, perfect. Because m technically to the power of 1, but we don't need to put that 1. M, okay? So our factored form is m squared times m minus 1. So we started with 2 terms, and we have 2 terms inside the brackets, okay? That's why it's not 0, it's 1. Here. And here, 1, 2, 3. We have 1, 2, 3 inside of those brackets. Okay? So you always have the same number inside the brackets as you started with. Is that right? Perfect. Okay. Okay, number 5, negative 12y squared plus 18y cubed plus 6y to the power of 6. First, look for, is there a common number? 6, good. Because we can divide 12 by 6, we can divide 18 by 6, and we can divide 6 by 6. But remember, we have a negative out in front. We don't want that negative in front inside the brackets. So it won't just be 6, it'll be negative 6. Perfect. So because of that negative, we want to divide by negative 6. So that's our number. Do we have letters that we can divide out?
Yes.
Yep. So they all have a y. So what's the y with the lowest exponent? 2. So y squared, and y squared. Okay, so our greatest common factor is negative 6 y squared. So we put that out in front of the brackets. Okay, now you want to divide each of these in parts, so look at the numbers first and then the letters. So if I just look at negative 12 divided by negative 6, what would that be? So it would be 2, but what happens when we divide a negative by a negative?
Oh, well, just 2.
Perfect, it becomes positive, okay? Just like when we multiply negative times negative, it becomes positive. When we divide negative by negative, it's also positive. Okay? And then y squared divided by y squared. 1, okay? So we say that they can just cancel out, so we'll just have 2 by itself. Okay? Now, 18 divided by negative 6. So we have a positive and a negative, so is it going to be a positive or a negative? That's the final answer. Negative, good. So minus 18 divided by 6. You can use your calculator if you want. 3, perfect. So we'll have negative 3. Now let's look at the y's. We have y cubed divided by y squared. Perfect. Just y by itself. So it becomes negative 3y. Our last one. We have a positive divided by a negative, so is it going to be positive or negative? When we have positive and negative?
Oh, negative.
Negative, great. And then cover up the y for a minute. 6 divided by 6 is 1, okay? So I'll put the 1 here for now, but I'm probably going to get rid of it. because we have y to the power of 6 divided by y squared. So we're going to do 6 minus 2.
Y4.
Perfect. So I'm just going to get rid of the 1 and just leave that as y to the power of 4. Okay? And that's our final answer. So remember, we have 1, 2, 3 terms to start, and we end with 1, 2, 3. Okay. Let's start this one together, but then I want you to finish the factoring on your own. What's our common factor going to be for negative n to the power of 5 plus 3n squared minus 2n? Just the m. Perfect. So we'll have m divided by m and divided by m. But what about that first term?
Wait, will it make a difference because M just needs one when it just made the same thing? Wait, are we dividing?
We're going to divide, yeah.
But doesn't one just stand for a single number, like 1?
Yeah, but because it's the m, we're going to be factoring out the m's.
Oh,
Okay? But remember, the first number is negative. So what else do we have to factor out?
We have the numbers and change them into the opposite of what they were.
Perfect. So we're going to be changing them into the opposite, and by doing that, we divide by negative m. Okay, because this one is negative. Okay, so we have equals negative m. Okay, so we have negative m to the power of 5 divided by negative m. That would be, what happens when we have technically m to the power of 1, okay? So I know everyone's pretty much got it. So what was the first term inside the brackets? M to the power of 4, perfect. And it's positive because we have negative divided by negative. Second term, we had 3m cubed divided by negative m. Perfect. And what's it, positive or negative?
Negative.
Perfect. Negative because we have positive divided by the negative. And power 2. And the last term, what happened? Elena?
It's 2 because negative minus negative, minus negative is 2.
Perfect. Because these cancel out, just become 1. Negative divided by negative is positive. So old CDs used to highlight these notes where you could like write in like stuff about the information, or it come with a little song listing. But it just looks like a rectangle. Okay. So this question says the liner notes for a CD form an area represented by the binomial 12x plus 3x squared. Okay. Now we want to write an expression for the dimensions of the liner notes by factoring the area. Does anyone know what the dimensions would be? What we're looking for? What's that? Perfect. So we're looking for the length and we're looking for the width. Okay, so it's for length and width of this rectangle. Okay. So yeah, like you said, area equals length times width. Okay? And we're also told that the area is the same thing as 12x plus 3x squared. Okay? So if we factor this, we'll have two things multiplying together. So when we have two things multiplying together, we'll have our length times our width. Okay, so we factor it, and then we'll be able to find the length and the width of it.
Where, length and width, area, length and width.
Yeah. So remember,
Like grade 7 or something.
when we factor something, we find the greatest common factor for the numbers and for the letters. Okay, so it's always the biggest number and the lowest letter. Okay. So what's the biggest common factor for numbers? For 12x and 3x squared. It's the biggest one that can go into each of them. 3, perfect. Because we can divide 12 by 3 and we can divide 3 by 3. And then we have x and x squared. So because we have an x in both of them, we can factor out something. Do we factor out x or do we factor out x squared?
That's like,
X squared or just x? Why just the x? Because we always want the lower one, right? We don't want the x squared, we want the lower one. So perfect. Be it 3x and 3x. Okay. So we take our greatest common factor, put it out in front. 3x. And then whatever we divide by gets put into the brackets. Okay, so 12 divided by 3 would be, I think I heard it. 4, perfect. And then x divided by x. X divided by x.
that was one.
They cancel out, right?
Just one.
What's 3 divided by 3? Okay.
0, 1.
And then 3 divided by 3 would be 1. So plus, I'll put the 1 in for now, but we won't need it because what's x squared divided by x?
1, just X.
Just x by itself, okay? So we'd have 1 times x or just x. Okay? So that x kind of cancels out with 2. Up there, okay? So we're just left with 3x or just x. Then the 3's cancel out too. Okay, so our area equals 3x times 4 plus x. Okay? So we factored it. Now, how do we find the length and the width? Remember, area is length times width. So we have area equals something times something else. We can just call them length and width. So I'll say that 3x is length and 4 plus x is width. Okay, because they're multiplying together. So therefore, our length is going to be equal to 3x and our width is 4 plus x. Okay, so we factor it, find two things to multiply together, then that's our length and our width. It doesn't matter if like we were to switch them. If we said that 4 plus x is our length and 3x is our width, it doesn't matter. It's kind of arbitrary. I always go whatever we have up front is length because we usually write length for width. Because I want to see everyone follow me on this jump.
Literally. Literally.
I'm just writing it back up there so that I have it on the screen. Okay. So find the actual dimensions if x equals 6 centimeters. Okay. We have our length is 3x and our width is 4 plus x. So we can find the actual dimensions by subbing in x. Okay. So our length equals 3x. So our length equals 3, and then I'm going to sub in 6 for x. So I'll have 3 times 6. So what's 3 times 6? 18. 18, perfect. So our length will be 18, and then in centimeters because we have centimeters for the x. Okay, and then we do the same thing for width. So our width is 4 plus x. So I'm going to sub in 6 for x again. The width equals 4 plus 6, and then 4 plus 6 is 10. Perfect. Okay, so our dimensions would be 18 centimeters and 10 centimeters. Okay. C. We want to determine the algebraic expression for the perimeter. Okay. So when it's algebraic, that means we want x's. Okay. We're going to have x in our perimeter. Okay. So what was the perimeter of a rectangle? Remember that from last week? Perfect. So our perimeter equals our side plus our side plus our side plus our side, okay? So you do it like that, I'm just gonna call it L plus W. So L plus W plus L plus W. Okay, so just add up all our sides together. If you do 2L plus 2W, you'll get the same answer. Okay?
Oh yeah.
Okay, so what was our length algebraically?
No.
So it's 18 centimeters, but we want it algebraically, okay? So we want to have x in it.
So it would be 3x.
Yeah.
Perfect, 3x. So do 3x, then our width algebraically would be, we have 3x plus,
4x.
perfect, plus,
I wrote one.
yeah, that's fine. So we take 3x, sub it in, then 4 plus x is our width, we sub that in, then we add it to another 3x, then we'll add it to another width, which is 4 plus x. Okay, so we do 3x length plus our width, 4x plus length plus width. So it's 3x plus 4 plus x plus 3x plus 4 plus x. Okay. So now I want to simplify this together using all of our like terms. Okay, so I'm going to bring all the x's together and then all the numbers at the end. So I have 3x plus x plus another 3x plus x, okay? So all I did was move all the x's up to the front, and then I'm going to push numbers to the back, where I have a 4 plus 4 and plus 4. Okay? So now all of these are the same, I can add them up. And all those are the same, I can add those up as well. Okay? So, what is 3x plus another x plus 3x plus another x? How many x's do I have altogether there, Robbie?
6x4.
So we have 3 plus 1 plus 3 plus 1.
8.
Perfect.
8x.
So we'll have 8x, and then 4 plus 4 is another 8. So we'll have 8x plus 8. Down. Okay, and I'm just gonna circle it to show that it's my final answer. So 8x plus 8 would be our algebraic expression for the perimeter. Okay, now for part D, we want to find the actual dimensions of the perimeter using our dimensions from part B, which were our numbers. Okay? Okay, so we want to find the perimeter again, but this time we want to use the actual dimensions, okay? So we want to use the numbers that we actually got. Okay? So what we're doing is we're solving it two different ways. We're going to solve algebraically, and we'll solve when we put in our numbers and make sure that they equal each other, because they should. Okay? So our length, we said, was 18. So I'll have 18 plus my width was 10. Plus another 18 plus another 10. Okay? So then we can add them all up. Put it into your calculator. 18 plus 10 plus 18 plus 10 gives us, perfect, 56 centimeters.
And I know that. That one's pretty easy.
Okay, so we just take the numbers that we calculated from B.
No, this was A.
This was
B.
and then this was C.
Okay. Our last step. So in D, we found that the perimeter is 56 centimeters. Now, our last question. We want to check our answer by subbing in x equals 6 centimeter into the perimeter equation that we came up in part C. Okay? And then it should match what we got in part D. Okay? We found that P equals 8x plus 8. Okay? That's what we found in part C, right? So now we're going to sub in that x equals 6 again. Into this equation and make sure that it equals 56, what we found in part D. Okay, so P equals 8 times 6 plus 8. Okay,
Equal.
so now remember, we want to do bed math, right? We want to multiply first and then we'll add at the end.
8 times 6 plus 8.
Perfect, so we'll do 8 times 6, no, add 8 after that.
48.
Perfect, 8 times 6 is 48,
48 plus 8.
then we still have the plus 8.
48 plus 8.
48 plus 8 would be
56.
56.
Agree? Meaning that this is the same as what we got for D, meaning we did it right.
Exactly, perfect, Tristan. So therefore, it's the same as part D.
We calculate it therefore.
You just write yes and matches.
Okay.
Okay. So the point of that is just to show that you can calculate two different ways. You can sub in x first and then multiply them together, or you can solve algebraically and then sub in at the very end. Okay? Both methods get you the exact same answer.